When we eat, the body has to deal with a lot of nutrients being delivered through the stomach and intestines, and from there being absorbed into the bloodstream. Once it arrives in the blood, fat, carbohydrates, and proteins need to be either used or else stored away efficiently. Failure to do so, such as if there's a large and sustained increase in carbohydrates or fats, can lead to increased risk for diabetes, along with liver or cardiovascular diseases. Exercise is known to help the body more efficiently metabolize food after eating, but exercise doesn't always happen in perfect weather. Stephanie Munten from Laurentian University in Canada, where it's very cold for a good part of the year, asked the question of whether performing exercise in cold conditions changed the amount of fat versus carbohydrates that you used during the exercise, and also how you responded to eating the next morning. To do this, 11 young, healthy, but overweight men and women performed an identical exercise session in the evening in either normal room temperature of 21 degrees Celsius or else in a cold room of 0 degrees Celsius. This involved 10 1-minute of hard cycling with 90 seconds rest in between. These are the graphs of the 10 by 1 minute intervals and the amount of fat or carbohydrate used during them. Overall, the total amount of energy used was similar between the two temperature conditions. But in the cold conditions, seen with the open circles, more of that energy came from fats than when exercising in normal room temperature. At the same time, there was a trend towards less use of carbohydrates. The second half of each experiment came the next morning, when participants returned to the lab and were given a high-fat meal including cheese, eggs, and avocado. This high-fat meal was used to really stress and overload the body. In both trials, they then sat in a normal room temperature for 4 hours. Over those 4 hours, no difference was seen in the total energy being used or how much of it came from fat or carbohydrates. In the blood samples, no differences were seen in the amount of insulin, fat, or cholesterol over the 4 hours. However, they did find a greater spike in blood glucose and an overall higher blood glucose throughout the 4 hours following cold exercise the previous night, suggesting a possibly worse ability to regulate metabolism after exercise in the cold. So overall, Munten and her team found that high-intensity exercise in the cold increased the reliance on fat to fuel that exercise. This may be useful for reducing body fat. However, exercising in the cold may have a slight negative impact on the ability to regulate metabolism the next day. This might be due to an overall higher degree of stress from the combined impacts of both exercise and cold. I hope that you've enjoyed this look into the fascinating world of environmental physiology. I'm Professor Stephen Chung, and I run the Environmental Ergonomics Lab at Brock University in Canada. Check out our other short environmental physiology videos or our longer, more detailed environmental ergonomics symposium series. Thanks for watching. See you next time.